All right, now it is time to look at altitudes and the orthocenter. Altitudes come from this idea of height. So if we're going back to looking at the area, we would take the measurement of the base, but then we would need the height. The height is not BC. The height itself is not AB, but it's actually what's perpendicular here. We call it the height. It's also called the altitude. What I'm noticing a lot on there is a lot of you guys are still using a perpendicular bisector. I don't want to cut this in half. I want to be perpendicular to this line through B. So I'm going to take my perpendicular line tool and I'm going to go perpendicular line through B through C. And so that is, or through AC, that is my perpendicular line. I think what a lot of students struggle with is the fact that not always through that. This line is still perpendicular to this side. I just couldn't come over here, right? Because if I did anything over here, it would no longer be perpendicular. This is the only place where this will be perpendicular to this line. And we can kind of see that is if I kind of extended it through and then I did my fanciness of changing that to a dotted line and maybe even changing the color, you could see that, okay, this is how it extends, so it's still going through there. But remember, on these types of triangles, when you're finding area, that is still how you find the height right there. That's the height of the triangle, not this section right here. So I think that's what students struggle with a lot on here. But if I continue building this up, so I do perpendicular through this side, through that vertex to that side, and then I do a perpendicular line between this vertex and this side. And notice how it's not through this side, but it's perpendicular. And so it's all the way down there. I have another nerd out moment of a point of concurrency. So that gives me what we call the orthocenter. And that was on the notes that we saw earlier. And so looking at the orthocenter, sometimes it's in, right? If it's a right triangle, it's actually the vertex, and then other obtuse, it's out. And so it's the same side thing as a circumcenter. Sometimes it's in, sometimes it's on, sometimes it's out. There's nothing really special. Orthocenter is part of an Euler line, which I might make a video of and show you guys that Euler line, where that is in a triangle. But unlike the median and the circumcenter and the incenter, there is nothing really special that we're going to use. We just want to know how to find it. And so the biggest thing that I want you guys to take away from the day is if it's an acute triangle, it's easy, right? Oh, it's perpendicular, perpendicular, perpendicular. But as soon as I get to an obtuse, we start to freak out a little bit, but we still want to know that that's still perpendicular to that line. We may just have to extend that line out. And so if you guys are doing that extension, you guys might see it a little bit better. But that extension is not necessary. Just know it's there. So that is what I have to say about the Orthocenter. Finish the notes, finish the homework, email me, and make sure you guys pop in and say hi at some point.